Okay, good evening. We're going to learn today, we're going to continue to learn about electromagnetic induction. That is called chapter 3.3, subtopic 3.3. Okay, electromagnetic induction. Okay, what is electromagnetic induction means? Is production of induced current. Production of induced current by the changing of magnetic field. Okay, I will teach you slowly because we're going to see physically, we're going to see 18 July, we're going to see each other. So I will teach you detail again. Okay, I'll teach again, but I'll introduce to you today. Okay, so production of induced current by the changing of magnetic field. Induced current, production of induced current by the changing of magnetic field. Okay, the word that you must understand, induced current. That current is produced. This current is produced. Electric current is produced by the changing of magnetic field. That means you must disturb the magnetic field in order to produce current. You must disturb the permanent magnetic field or electromagnetic field also can in order to produce current. Okay, so this current is the same. The current, battery current, induced current is same. Battery current, induced current is same current. Battery current is a chemical reaction. Chemical reaction produce current. But induced current different. Induced current by the changing of magnetic field. By disturbing the magnetic field. You disturb the magnetic field, you produce current. That is called induced current. Induced current. Okay, and induced current is produced when? Induced current is produced when? Satu, a conductor cuts across magnetic field, magnetic flux. Okay, a conductor cuts across magnetic flux. Induced current is produced when a conductor cuts across magnetic flux. A conductor cuts across magnetic flux. That is called induced current. Induced current is produced when a conductor cuts across magnetic flux. Okay. Number two is change in magnetic flux linkage with the coil. Change in magnetic flux linkage with a coil. Okay, so the two ways you can produce induced current. First method, a conductor cuts across magnetic flux. A change in magnetic flux linkage with a coil. What is the meaning of magnetic flux and magnetic field? Okay, the magnetic field is the field. Okay, the field between North Pole and South Pole. The field, Medan. Magnetic flux means the lines. The lines that joining North and South Pole. The lines. Okay, magnetic field is the field or Medan between North Pole and South Pole. There's a field. Magnetic flux means the field lines. Okay, north and south field lines. It cannot be visible. Cannot be visible until unless you put iron fillings. Iron fillings, you can see something with the lines. Okay, some iron fillings, but cannot be visible. Okay, naked eyes cannot see. But we can put it the iron fillings, can see the linkage. Okay, now the first magnetic field, flux, magnetic field, and so on. Okay, the first one, the first induced current. Electromagnetic induction means production of induced current by the changing of magnetic field. By the changing of the magnetic field. Okay, for example, this North Pole, this is South Pole. Okay, now between North Pole and South Pole there is a field lines. 1, 2, 3, 4, and 5. Okay, the field lines. The magnetic field lines is the one we call magnetic flux. Magnetic flux. Okay, this is a magnetic field. Okay, in the what do you call it? This one we call it this conductor AB. This conductor AB connected with a galvanometer. Connected with the galvanometer. Normally we learn 3.2 in the motto. We learn a battery and the conductor AB. There's no battery here. No battery here. That means there's no current is supplied. Current is not supplied. Current is produced instead. Instead, current is produced. Okay, by the changing of the magnetic field. Okay, wire AB. Wire AB is a magnetic flux. And north and south pole. Not the south pole. So, for this you must use Fleming's right hand rule. Fleming's. This is number one. Conductor AB cuts across magnetic flux. Conductor cuts across magnetic flux. Number one. Induced current produces two methods. One is a conductor cutting across magnetic flux. This is number one. Number two, magnetic change in magnetic flux linkage with the coil. Coil also can produce coil. Coil also cut the flux. I'll teach you later. Number one, number two. Okay, number one, Fleming's right hand rule. Fleming's right hand rule. Thumb shows what? Thumb shows what? And the pointing finger shows what? And pointing finger, the middle finger. The thumb shows what? The force. Direction of force. Okay? Direction of force. Thumb shows direction of force, and the pointing finger shows direction of current. Pointing finger direction of magnetic field. Okay, north to south magnetic field, and the middle finger direction of current. Okay. What is the difference between Fleming's left hand rule and Fleming's right hand rule? Fleming's left hand rule is a Moto rule. Okay, Fleming's left hand rule is a 3.2 Moto rule. That means the left hand rule. Okay, it's left hand rule. Is a thumb shows direction of force, and pointing finger shows direction of magnetic field, and middle finger shows direction of current. Okay, in the left hand rule or Moto rule, we have to give two inputs to get one output. These are two inputs. We give the magnetic field as an input. We give input, and the current, battery current or AC current or battery current. We give input as magnetic field and the current as an input. Output we got force. The force Turning effect, you remember turning effect? The output. Output is a force. Okay, that is left hand rule, motor rule. Right hand rule, thumb shows input, the input. This is input. This is input. Force input. And we call it magnetic field input, and the current is output. Current is output. Okay, I will teach you this again when you come to see when you see in the class. Okay, I'll teach again. But you must understand this first. Okay, you must understand this first. Fleming's left hand rule. Sorry, Fleming's right hand rule. Fleming's left hand rule, we learn motor rule. We learn, we call the motor. We learn motor, how to turn the motor. I thought this one. Fleming's right hand rule is electromagnetic induction. Electromagnetic induction, thumb shows direction of force. Direction of force, input. Pointing finger, direction of magnetic field, input, and the output we get current, output. As a result of this one, we got current, because current is not supplied. Motor rule or Fleming's left hand rule, current is supplied, current is diberikan, current is supplied. But here, current is produced. Okay, you must understand this very well. You must understand this one. Current is produced. This is current is produced. Okay, I don't further. Okay, maybe. Okay, North Pole and South Pole. Okay, this is okay. This is the North Pole and South Pole. This North Pole, this is North Pole, and this is South Pole. Imagine this North Pole and South Pole. There's a magnetic flux, magnetic lines, magnetic field lines. Okay, the North Pole and the South Pole, magnetic field lines. Okay, the first thing we have to do, we have to take the conductor. Okay, we have to take the conductor. Conductor cuts through. This is conductor AB. So it cuts through magnetic flux. Cut across magnetic flux. The first thing, how they produce induced current. A conductor. First thing, conductor AB cuts across magnetic flux. This force you must give. You must give the input. You must make the conductor to move. But motor, the conductor move itself. The motor is output. The force output. But here in the electromagnetic induction, the motor is we call it electromagnetic induction or Fleming's right hand rule. The force is you must provide the force. You must give the force. Okay. Now. AB, conductor AB. Okay, cuts across. Okay, we have to give the force. And the pointing finger shows magnetic field. So as a result of it, okay, pointing finger shows magnetic field. So right hand rule. This pointing finger shows magnetic field. And force, this one is force. This thumb shows force. So this one is this. Okay, this right hand rule, it's not left hand rule. Left hand rule is a motor rule. Right hand rule is right hand rule. Electromagnetic induction, Fleming's right hand rule. Okay, Fleming's right hand rule. Sorry. You must see. Okay. Now, this is pointing finger from North Pole to South Pole. The pointing finger always shows a magnetic field lines from north to south. From north to south. This is North Pole. This is South Pole. Okay. And the pointing finger and the thumb shows force. The force like this. The force pulling down the magnetic flux, cutting the magnetic flux, cuts across the magnetic flux. You cut. That is. So the current is flowing this way. Current flowing this way. Okay? Current is flowing this way. Current flowing this way. Okay? Okay, now this cuts across down. Cuts across down. So now when it cuts across upwards, when you move, it cuts in and cuts out. So cuts in, down. This cuts out. Cuts out also you can produce current. Okay. Okay, now pointing finger, North Pole, and the force is upwards. The force upwards. Current is moving this way. Okay, I repeat again. Okay, now when you North Pole, South Pole, when the force acting downwards, you must provide the force. You must provide the force. You must cut the flux. So the conductor AB, this is conductor AB. This wire is conductor AB. Okay, this force. This cuts in, the current is moving like this. And cuts out the current. The force is like this. Force upwards, current. The pointing finger same. North Pole. The current is the force upwards. The force cuts out. So this current is this way. So cuts in, current this way. Cuts out, current this way. So cuts in, current this way. Cuts out, current this way. Cuts in, current this way. Cuts out, current this way. Cuts in, current this way. Cuts out, current this way. So what do you understand from this here? Induced current always flow two directions. Current in, out. Current is always flow in two directions. Unlike the battery current always flow in one direction, from positive to negative. Current flow always one direction. That is called DC current. Direct current. But induced current is always flow in two directions. Current in, out. According to cuts in, cuts out. Okay, that's one difference. Battery current, induced current. Both also measure ampere. But battery current flow in one direction, positive, negative. But induced current flow in two directions, cuts in, cuts out. Current flow in, flow out. Flow in, flow out. Flow in, flow out. So the current is okay. This current is flow in here, flow in here. So flow out, flow in, flow out. Current is two direction. Current current is flowing in two direction. That's one difference between induced current, battery current. Battery current flow in one direction. Induced current flow to two direction. Another difference. Battery current is always flow as long as switch on. As long as switch on, the current always flow. But induced current always flow only when it cuts in, cuts out. Cuts in, current. Let's not show the hand. Cuts in, flow this way. Cuts out, flow this way. Cuts in, flow this way. Cuts out, flow this way. Cuts in, cuts out. But you stop cutting the flux. This is flux. Magnetic field lines between north and south. Magnetic field lines. So the flux. You stop cutting the flux, you stop producing current. That's the difference. The two difference between battery current and induced current. Battery current always flow in one direction only, positive and negative. The induced current always flow in two directions. Like this. like this, like this, like this, like this. Always flow two direction. Second difference, battery can always flow as long as battery is switch on, or battery can be okay, as long switch on. But induced current only flows when you move the conductor, move in, out, move in, out, in, out, in, out, in, out. You have to move in the conductor. But if you stop moving the conductor, you stop producing this current. You stop producing this current. The moment in the midst of magnetic flux, okay, it's a mix of the conductor is a mix of magnetic flux, like this. But current stop flowing because no movement. Force must have movement. The force of movement. Force must move in, out, in, out, in, out, in, out. Cuts in, cuts out, cuts in, cuts out. In other words, I will tell you a different way. You disturb the magnetic field, you produce induced current. You don't disturb the magnetic field, you don't produce induced current. That's idea. You disturb. Because even the conductor in the midst of magnetic flux, even the conductor in the midst of the magnetic flux, the conductor is kept in the midst of the magnetic flux, but current is not produced. Current is not flowing. The midst, but you must move. You must move. That is called induced current. That is called induced current. And Fleming's right hand rule. Another way induced current can be produced. We call it magnetic field linkage with the coil. Magnetic field linkage with coil. This one. Okay, number 2. This is number 2. Okay. Okay, this is another galvanometer. This is a galvanometer. Galvanometer, zero-center galvanometer. The galvanometer is not number 1. The galvanometer will move in left, right, because current is moving to two directions. So left, right. So the galvanometer here also move left and right. So galvanometer here also move left and right. Okay, this is one. This is magnet. North pole and south pole. Between North Pole and South Pole, there is a magnetic field. This is field lines or magnetic flux. This is number 2. Okay, linkage with a coil. We call it change magnetic field or change magnetic field or change magnetic flux linkage with the coil. Okay, this one, how to do it? This one is you push in the magnet, then the flux will be cut by the coil. That's induced current. Induced current produced. And this one, push in and pull out. Push in and pull out. Push in and pull out. So the current produced this two way. Current same current, induced current, two ways also. Push in, maybe current this way. Pull out, current this way. Push in, current this way. Pull out, current this way. Push in, current this way. Pull out, current this way. So the current also always produced in two ways. This is also this is called coil. That's now a conductor, but we learn more this one. We learn this one more. Okay, coil and conductor. Conductor is a simple conductor. Cuts in, cuts out, cuts in, cuts in, cuts in, cuts out, cuts in, cuts out, cuts in, cuts out. So the current flow like this two direction. But here magnet push in. The magnet push in. That's now the magnet is here. The magnet is here. Magnet doesn't move, but we move the conductor. We move the conductor, cuts in, cuts out, cuts in, cuts out, cuts in, cuts out, produce current. Okay, but this one here, the coil is this stationary. Coil is stationary, but magnet push in, pull out, push in and pull out. In other words, the coil also can push in, push out. Same. The coil also we can put magnet stationary. The coil will push in and pull out, push in, pull out also same. Okay, this is a induced current, produced induced current. This is a second method. So induced current, you learn something like induced current is a current that is produced by the changing of magnetic field or disturb the magnetic field. Disturb the magnetic field. As long as you don't disturb the magnetic field, there's no current. You must disturb. You must push in the magnetic field or lines cut by the coil. That's a current produced. So as long as you don't disturb the magnetic field, the current is not going to produce. Okay. Okay. So I will end up this session today. And there's another 2 ways to learn Lenz's law and Faraday's law. Is too tedious lah. So Lenz's law and Faraday's law is something like we have to learn more things lah. Okay. So today we learn Fleming's right hand rule, Fleming's left hand rule. Fleming's left hand rule we learned last week, the Moto rule. Fleming's right hand rule we learned today lah. Today we learn. Okay. The Fleming's right hand rule is electromagnetic induction rule. Electromagnetic induction rule. Okay. And I will like to see 18 July we are going to meet again. 18 July next week I give another class. Maybe next week or like this. Okay, 18 July Saturday class we are going to see. And Monday 20th Monday and 21st Tuesday we're going to see the class. We're going to meet again. Okay, there's Saturday and Monday and Tuesday. Saturday 18 July, God willing, by God's will. Okay, God willing, we're going to meet on 18 July and 20 July and 21st July. Okay, and we're going to learn. We're going to learn now. We got electromagnetism. I will refresh your memories on the Moto, Fleming's left hand rule, and the Fleming right hand rule. I'll refresh your memory. Okay, and we're going to learn so much things through this chapter 3. The chapter full of laws, about 5 laws you must learn. 5 laws. Okay. And the law application of law important. This topic is very, very famous topic in SPM. Very famous topic because one reason, less calculation this topic. Very, very minimum. About 95% is about theory only. About 5% only. 5% about calculation. About 5 or 10% calculation. Okay, but 90% over is theory. So this topic, but it's an interesting topic, but at the same time, it is some tedious thing, something law. You must know the law. You must know the Fleming's left hand rule, Fleming's right hand rule, right hand grip rule. Right hand grip for 2 sections. Right hand grip rule, conductor and the coil is different. Right hand grip rule, solenoid we learn. So many laws we learn. So we're going to learn. Okay, and I foresee this topic. Okay, I'll repeat again to you. Okay, the Fleming's left hand rule is a Moto rule. Fleming's right hand rule is a electromagnetic induction. Electromagnetic induction. It's a chapter 3.3, subtopic 3.3. Electromagnetic induction means production of current. The Moto rule, Fleming's left hand rule, you supply current, produce force or rotation. The fan, for example, Moto, Fleming's left hand rule. So you supply the current and produce the force, rotation. That is called Fleming's left hand rule. Fleming's right hand rule, you supply magnetic field and the force in order to produce current. So Fleming's left hand rule, you must give two inputs, magnetic field and the current. Fleming's left hand rule, in order to get force as an output, force rotation. The fan, for example, fan. Okay, fan, force is output. But Fleming's right hand rule, you must give the force. You must give the force. You must move the conductor or magnet. You must move the conductor or magnet. Okay, and magnetic field. Magnetic field both also. Fleming's left hand rule and right hand rule both also got magnetic field. Magnetic field is supply. So magnetic field supply, force supply in order to produce current. So I will end up this session today with this. I'll clearly explain to you. I hope you can understand this one, and we'll see you again next class. Okay, thank you very much.